Great. Great, and I can't get out. We get out.
Okay, here we go. Here we go. Hey, stop your conversations, please. So we talked about some things, and we talked about the quadratic formula. This goes back a little while ago. We said some important things. We said that in the quadratic formula, there's a portion of the quadratic formula. Let's go back to that. Where was that? Oh, right here. We can just do it right here. So here's our quadratic formula, right? The part that's under the radical is important. We call that the discriminant because it discriminates between the three kinds of outcomes that we can have, right? We can have, what if the discriminant, when I plug in those numbers, b squared minus 4ac, yields a positive number? What's guaranteed to happen? And just don't look away from this. Nothing to see there. See if you can remember. What's it going to be? Two real solutions, right? And it makes sense because if I'm taking the square root of a positive number, I'm getting real answers, aren't I? Two real results. When I say two, I mean one for the plus and one for the minus, right? Because I've got negative b plus or minus whatever the square root of the discriminant is going to be divided by 2a. So if the discriminant's a positive value, I know that I'm going to get two different answers for the plus and the minus, and they're both going to be real, okay? What if the discriminant is negative? Well, if I've got a negative number under the radical, what am I getting? Get imaginary solutions, right? And I'm going to get two of them, one for the plus and one for the minus. So if the discriminant is negative, I get no real solutions and I get two imaginary solutions. And then the boundary between the two, if the discriminant happens to be exactly 0, then I get the square root of 0 is what? 0, yeah. So I get negative b plus or minus 0. Well, that's the same thing, right? Adding or subtracting 0 doesn't give me different results. So in the event that the discriminant is exactly equal to 0, we get one real solution. Okay, now we could look at this in real time. And this is I kind of want to show you guys a little more about this anyway. I'm going to have you maybe, when we get down towards the end of the year, I'm thinking about some project stuff for you guys. And this would be something that seems like a pretty good idea. So if we did, let's just go into Desmos, and let's pick some, I'm just going to write a function that's going to be a random quadratic function. We're going to choose the values of a, b, and c. Okay? So just watch how you do this. So I'm going to define a function in Desmos, a times x squared plus b times x plus c. And it's going to wants to know, do I want to add some sliders? Yeah, I'm going to do that. So I get to pick some, these are going to be sliders where I can just pick random values for a, b, and c. Okay? All right, so I'm going to calculate something else down here. I'm going to calculate d is going to equal the discriminant. So that's going to be the square root of b squared minus 4 times a times c, and it's going to calculate values for the discriminant. Okay? Well, 0 wouldn't make any sense. A should really never be 0, should it? I mean, a being 0 means this isn't quadratic. So let's make a some positive value. Okay? Now I want you to tell me here, based on the value of, and I want to cover this up too. Let's see, how can I do this? Yeah, like this. Okay. Why does it say the discriminant's undefined there? Because it's negative. Oh, actually, I just want the discriminant, not the square root. Yeah, we'll do that. Hang on. I'm taking the square root of a negative. There. So I get some negative value, right? Okay. So here's going to be your first team question. These are going to be pretty easy ones. But I want you to tell me, I'm just going to randomly mix these things up here a little bit.
In our head.
Yeah, I just mixed it up, okay? So in your groups, I would like you to tell me real quick, and don't say it out loud, but just discuss it with your group. I'll give you 30 seconds. I want to know what's the sign of the discriminant right there. What's the sign of the discriminant? Okay, and tell you what, let's do this. Marie, would you give each group one of those little portable whiteboards? And everybody, each group, make sure you grab a dry erase from the side there somewhere. So that's question A. We'll call this question A. You're going to write down 4 different answers on this, okay? So question A, I want to know what's the sign of the discriminant right there. Okay?
Where do they get the markers? Your markers?
Just on the side there should be some. Everybody, send one representative from your group to grab a marker from the trays on the side.
Where the markers? Oh, this is the
Okay, there's question A. Positive or negative? Hold that thought. So there's question A. Okay? Right there. Here's question B. Oops. Oh, man. There's question B. Right there. I'll run through them one more time too before you. Okay, and okay, I got to think about this one real quick. How I'm going to do this.
Get more than you never do.
I know.
Not until it started winning. Oh yeah, service. Yeah. It's crazy.
Okay, there's question C right there. Okay, one more time. There's A. Oh, sorry. There's A. I want to know what's the sign of the discriminant. There's B.
It's frozen.
Oh, whoops. Hang on. So, there's A. Sorry. There's A. Sign of the discriminant.
There's no numbers.
You don't need to see them.
Okay.
You can look at the picture. That's all you need is the picture.
Okay.
B. Look at the graph. Want the sign of the discriminant. And C. The sign of the discriminant. Okay, take another 20 seconds.
Can you do A real fast?
Yep, you betcha.
What am I looking at right now? What are you
So there's A.
Yeah.
Okay, once again, there's A. There's B. There's C. Okay, like I say, take another 20 seconds or so. I'll be generous.
Give me reverse psychology.
Oh no, what'd I do? You gotta be kidding me. There we go.
What's the
Okay, here we go.
Do we put our boards in?
Okay, let's see your boards. Okay, 2 out of 3. Good. Spot one.
Wait, we're changing
Okay, who?
based on the.
Okay, was that an official group change?
Yes.
Okay, good. Got them all? Yes. Okay. All right. So explain to me, somebody, real quick. Here's part A. Actually, here's part A. Why is it positive?
There's two.
Okay, that doesn't have to do with the graph going up.
Two solutions.
There's 2 solutions. Look, there's 2 real. There's 2 x-intercepts, right? X-intercepts correspond to real zeros. Okay? So we can see from the graph there are 2 real zeros there because it crosses the x-axis twice. Okay? So then by that logic,
Oh.
what's the answer here? Discriminant is negative. It's negative because there are no real solutions, right? The real solutions would correspond to x-intercepts. Okay? There aren't any. So how many imaginary solutions are there here? 2. Have to be. Okay? And then finally, what about this guy here? It's 0, and what's your thinking there? How come?
Only one solution.
Only one solution, so the discriminant must be equal to 0. Good. Okay, so I'm going to give you guys a chance to put up your points. All right, hang on here.
Enemy.
Is this for a basketball game?
This is for a basketball game. This is for the playoff game coming up.
Is that a home game?
Yes.
Are the numbers gonna be random again?
Yes.
Wait, is it home?
There it is. It's got to be like orange or something. Okay, there it is. Bucks and the enemy. And I'm going to delete all these because these are from calculus. Okay, so each group, you know your groups. You guys only get 1 because yours was partial. The rest of you guys get 3. There you go. Actually, only 2. That was easy. You only get 2. 2 for a correct answer, 1 for partial.
Where should I put it?
Just go anywhere.
Here, let me get you there. Oh, hang on. You gotta. Oh, you're good. You go. You're good. 2. Hang on one sec.